China's robot factories did not appear overnight. They emerged from decades of industrial expansion and relentless pressure to produce more. The old model depended on abundant labor, long shifts, and millions of workers performing the same task again and again. But rising wages, an aging workforce, and global competition began to weaken the advantage that once made China the world's factory. Automation became a new source of power, replacing labor intensity with speed, precision, and machines that could operate continuously. Across China, factory floors started filling with robotic arms, automated vehicles, sensors, and software-controlled production lines. These are no longer simple factories with a few robots added. Many are being redesigned around machines from the beginning. On the assembly line, robots now weld, lift, place, fasten, and inspect components with almost no pause between movements. The goal is not only faster production, but tighter control over quality, timing, energy use, and waste. China is shifting from cheap labor to smart machines because automation makes output easier to scale and harder to disrupt. Older robotic systems repeated fixed motions, but newer machines can adjust their grip, angle, and force for different tasks. Software now sets the rhythm of the factory, coordinating machines so that every stage moves at exactly the required speed. The modern factory is becoming a data center, where production decisions are shaped by streams of information in real time. Every machine creates data about temperature, pressure, vibration, speed, defects, downtime, and the condition of each component. That data allows engineers to measure tiny movements that would be impossible for human supervisors to monitor continuously. When a robot performs the same task thousands of times, the factory can compare each motion and improve the process. This creates a manufacturing system that learns, finding weak points and refining production while the factory is still running. Electric vehicles have accelerated this shift because their batteries, electronics, and precision components are well suited to automated production. But China's automation push goes far beyond cars, reaching electronics, batteries, appliances, logistics, chemicals, and heavy industry. For manufacturers, robotic production can lower costs by reducing errors, shortening cycle times, and keeping machines active for longer. The difficult part is that workers must change too, because factories now need technicians, programmers, engineers, and system operators. New factory jobs require workers who can maintain robots, interpret data, manage software, and solve problems machines cannot handle. That creates both opportunity and pressure, as traditional roles disappear faster than many workers can acquire new skills. Automation can improve productivity, but it also creates job insecurity for people whose work consists of predictable physical tasks. China's demographic slowdown makes this transition strategic because a shrinking workforce could otherwise limit future industrial growth. Robots do not sleep, take holidays, or leave the factory, allowing production to continue through nights, weekends, and shortages. A single robot depends on a much larger supply chain of sensors, motors, controllers, chips, software, cameras, and precision parts. China is trying to control more of that robot supply chain instead of relying heavily on imported industrial technology. Government support, local manufacturers, research institutes, and factory demand are now reinforcing one another across the country. Robotic arms are only one category. Modern automation also includes mobile robots, inspection systems, cobots, drones, and warehouse machines. Electric vehicles have become a strategic testing ground where China can combine robotics, batteries, software, and mass production. Traditional industrial regions are being pushed to modernize, replacing old equipment with digital systems and more flexible production lines. As robot prices fall, smaller manufacturers can automate tasks that once required the budgets of only the largest corporations. Different robots now handle different problems, from carrying materials to assembling delicate parts and operating in dangerous environments. Humans still manage the system, especially when equipment fails, production changes, or unexpected situations confuse automated processes. The most valuable advantage remains high-end engineering, because reliability, precision, and integration matter more than simply owning robots. Hardware alone is not enough. Without strong software, a robotic arm is only an expensive machine repeating limited instructions. Real factory objects are difficult because they vary in shape, position, texture, weight, and condition from one moment to the next. Messy data and weak training can make a smart factory unreliable, causing machines to misidentify objects or make poor decisions. This is why robotics has become part of the artificial intelligence race, connecting physical machines with increasingly capable algorithms. Machine vision allows robots to recognize parts, inspect products, locate defects, and respond to what is happening around them. Autonomous logistics systems move materials through warehouses and factories without waiting for human drivers or manual instructions. Digital twins create virtual copies of factories, allowing engineers to test changes before applying them to real production lines. Predictive maintenance uses sensor data to identify abnormal behavior before a machine stops and interrupts the entire factory. When robotics and AI combine, the factory can move from fixed automation towards systems that adapt to changing conditions. Automation is changing global competition because countries now compete through industrial software, machinery, data, and production speed. That weakens the advantage of low-wage manufacturing, since machines can produce efficiently even where labor is more expensive. The old assumption was simple: higher wages would force factories to leave. Automation is breaking that assumption. Cheap labor is no longer enough when a highly automated plant can produce more consistently with fewer people and less downtime. The future contest may not be robot factory versus human factory, but integrated factory versus a factory that cannot modernize. Advanced manufacturing requires more than machines. It also needs training, capital, reliable energy, strong suppliers, and technical expertise. China is investing heavily because it wants automation to become a foundation of national industrial power, not a niche technology. The deeper advantage may be the ecosystem connecting suppliers, engineers, software firms, factories, universities, and government policy. That ecosystem is harder to copy than an individual robot because it depends on thousands of companies learning together. Machines are increasingly being designed around workers, assisting with heavy lifting, dangerous tasks, and repetitive physical strain. There are three broad futures. Automation supports workers, social pressure slows adoption, or machines replace people much more quickly. China currently leads much of the world in industrial robot installations, giving its factories enormous experience using automation at scale. A second scenario is growing social pressure if job losses, regional inequality, and retraining failures spread faster than new opportunities. A third scenario is global acceleration, where every major manufacturing country races to automate before competitors gain a permanent advantage. The most likely outcome is mixed, with human-machine factories, highly automated plants, and older labor-intensive production existing together. China will continue automating because its factories face rising wages, labor shortages, global competition, and pressure to move upmarket. Workers will need new skills because the safest jobs will increasingly involve maintaining, programming, supervising, and improving machines. The industries that adapt successfully may become more productive, while those that fail could lose orders and disappear from supply chains. The shift from labor to robotics does not remove competition. It moves the contest from worker numbers to engineering capability. Some future factories may operate with very few people, especially in controlled environments, producing standardized goods around the clock. Other machines will learn from production data, gradually improving speed, quality, and efficiency without being manually reprogrammed each time. The central question is no longer whether factories will automate, but who will own, control, and benefit from the machines. China's industrial future will depend on whether it can combine robotics, AI, supply chains, and skilled workers more effectively than its rivals. What began as a response to rising costs is becoming a much larger attempt to redefine how modern manufacturing works. The next era of manufacturing will not be built by robots alone, but by nations that learn how to organize entire economies around them.